Hello YouTube, this is video number 2 in my solving trig equations series, in which I'm confronting how to solve trig equations in which there are more than one trig function involved. So this is a little bit more complex than having just one trig function in which you isolate it or factor it. You're starting with more than one trig function. So as you can see here, we're starting with 4 cosine squared x plus 4 sine x minus 5, and this is all equal to 0. And we're allowing x to be somewhere between and including 0 and 360 degrees. So right off the bat, you'll notice that this would be difficult to solve if you had to deal with a cosine squared and a sine x. So in order to remedy this, we're actually going to try to find a way to maybe use some trig substitutions with trig identities to maybe transform one trig function into the other one so that we can just have one type of trig function. And so I'm going to go ahead and point this out here. Whenever you're dealing with a squared trig function, you're leaving the door open to use our Pythagorean identities. So the primary trig Pythagorean identity that you see quite often is sine squared plus cosine squared is equal to 1. And that's actually the one we're going to use and borrow here, but we'd like to substitute in for cosine squared of x this time. So I'd like to substitute in for this, which means we're going to have to isolate it in our trig identity. At least I can put it this way. It's a very good thing to get used to the fact that cosine squared is equal to 1 minus sine squared of x, as well as sine squared of x is equal to 1 minus cosine squared of x. But in this case, we're going to borrow from the fact that cosine squared of x is equal to 1 minus sine squared of x so that we could substitute this back into our equation over here on the left for our cosine squared, which would in essence make this entire equation all in terms of sines. So now what we end up with is this. We have 4 times 1 minus sine squared of x, okay, in place of cosine squared of x, plus 4 sine of x. This is minus 5 equal to 0. So now we're going to just tidy this up a bit by distributing our 4 over here on the left and then combining like terms. So what we end up with is this. 4 minus 4 of these sine squareds plus 4 sine x minus 5 is 0. Let me fix that real quick. Is 0. Furthermore, we have, let's go ahead and put this in standard position, or standard form, excuse me. So we have negative 4 of these sine squareds, and then we have positive 4 of these sine to the firsts. And then combining like terms, that is our negative 5 and our positive 4 here, we end up with minus 1 equal to 0. So now our method is going to be to factor this in order to solve it. And in order to do this, it's not a necessity, but it is convenient. We're going to go ahead and make this leading coefficient positive. So let's take everything on both sides of this equation times a negative 1. So we take it times negative 1 on the right, and we'll take it times a negative 1 on the left. Essentially just flipping all the signs on the left, and since we're taking 0 times negative 1 on the right, it's not going to affect what's on the right. So we have, oops, this is minus now, minus 4 sine x, positive 1 equal to 0. So now, factoring this, we know we need to get a 4 sine squared x in front, so we're going to go ahead and give, let's do 2 cosine of x and 2 cosine of x. Some people might recognize this as a perfect square trinomial. And then also we need to produce a positive 1 in the back here. So 1 times 1 or negative 1 times negative 1, but seeing as how we need to make a negative sum in the middle here, let's go minus 1 and minus 1. So it'd be easy to check this. If you check your outer and your inner multiplication here, you notice you get negative 2 cosine x and negative 2 cosine x, which gives us the minus 4 cosine x in the middle. And then our first and last on our FOIL works. So since this is factored, in essence it's like saying a number a times a number b equals 0, therefore one of them was 0. We can go ahead and set each of these individual factors now equal to 0. So 2x minus 1 equals 0. And as a matter of convenience, we don't need to set this one equal to 0 because it's identical. So we'll go ahead and add 1 to both sides here. We say, okay, so therefore 2 cosine of x equals 1. And then splitting both sides by 2, we get cosine of x is equal to a half. So taking the inverse cosine of both sides now, so cosine inverse of cosine of x, which cancels out the cosine there. X equals the same thing as cosine inverse of a half. In other words, this implies that x equals cosine inverse of a half, or the angle at which we get a cosine value of a half. So in order to examine this conveniently, we're going to go ahead and take a look at the unit circle here. And the unit circle essentially indicates that we get a cosine or an x value of positive a half when we are at 60 degrees or pi thirds radians, and also at 300 degrees. So 60 degrees and 300 degrees are our solutions to this equation. So 60 degrees, 300 degrees, or we have pi thirds and 5 pi thirds. Okay, so that's just kind of a straightforward example of what you would do in if you had a trig equation with multiple trig functions but one of them was squared. We typically try to work a Pythagorean substitution in there.